An interstellar comet, unlike anything ever seen, is now making its way through our solar system. It's called 3I Atlas, and astronomers have discovered that it is venting nickel vapor without iron and producing a carbon dioxide-dominated coma with almost no water. These findings are extraordinary because they break the rules of cometary chemistry as we know them. Some researchers even suggest it could hint at something technological drifting between the stars. Let's take a closer look at the data and what it might mean. 3I Atlas, officially designated C2025N1, is the third confirmed interstellar visitor after Oumuamua in 2017 and Borisov in 2019. It was discovered on July 1, 2025, early enough for scientists to track it well before its closest approach to the Sun. It will swing to perihelion in late October 2025 at a distance of about 1.36 astronomical units, then pass near Jupiter in March 2026, exiting the solar system forever. Unlike Oumuamua, which was spotted too late, or Borisov, which was faint and fast, Atlas offers a rare extended observational window. Its incoming velocity is enormous, about 60 kilometers per second, a signature of an object ejected from another stellar system long ago, perhaps hundreds of millions of years in the past. The first major anomaly came from the Very Large Telescope in Chile. Using high-resolution spectrographs, astronomers saw bright emission lines of neutral nickel in the comet's gas plume, but no sign of iron. That's strange. In astrophysics, nickel and iron are usually inseparable twins. They are born together in the fiery hearts of supernovae, they condense together in meteorites, and they outgas together in solar system comets. Detecting nickel without iron is like finding chlorine without sodium. It's chemically unexpected. Even more surprising, the nickel release was measured at about 5 grams per second at 2.85 AU from the Sun, and the production rate increased sharply as the comet approached the inner system. What could explain nickel without iron? On Earth, the only place we see such separation is in industrial refining of nickel alloys, where nickel is purified through chemical channels, such as the nickel carbonyl process. That is why some scientists, including Harvard astronomer Avi Loeb, have speculated about artificial origins. But the mainstream interpretation favors more exotic natural chemistry. The VLT team suggests that low-temperature processes could be at work, photon-stimulated desorption, in which sunlight knocks nickel atoms free from nanograins, mild thermolysis of nickel-bearing organic compounds, or unusual nickel-rich nanophases that release Ni more efficiently than Fe. These mechanisms don't require alien engineering. They just represent pathways that are unusual but possible in the diverse environments of the galaxy. The second anomaly comes from the James Webb Space Telescope. In August 2025, Webb's NIRSpec instrument observed 3I Atlas at 3.3 AU and found its coma dominated by carbon dioxide with far less water vapor than expected. The carbon dioxide to water ratio was about 8:1, one of the highest ratios ever measured for any comet. Normally, comets in our solar system have water as their primary volatile driver, with carbon dioxide playing a secondary role. But in Atlas, carbon dioxide is the main component. Other molecules were detected: carbon monoxide, carbonyl sulfide, and cyanide gas. Yet the absence of abundant water is striking. Why would this happen? One natural explanation is that the comet formed near the carbon dioxide ice line in its home star system, where carbon dioxide could condense in bulk while water was depleted. Another explanation is structural. If the comet's surface crust is highly insulating, water ice deeper inside may not yet be exposed, while more volatile carbon dioxide sublimates freely at greater distances. If so, the ratio might change as the comet nears perihelion and the surface heats up further. Still, the present readings make Atlas stand out as chemically unlike any comet previously studied. The combination of anomalies, nickel without iron, carbon dioxide without water, and cyanide emission, has sparked debate. Could these be the fingerprints of alien industry? Or are they simply the first glimpse of chemical diversity beyond the narrow sample of comets we know from the solar system? Advocates of the artificial hypothesis point out that nickel without iron is consistent with technological refining. Skeptics argue that with trillions of stars and countless planetary systems, it's inevitable that some objects will form under conditions that produce strange compositions. Even in a tiny sample of lunar soil brought back by the Soviet Luna 24 mission, scientists found a grain of pure molybdenum, a rare but natural anomaly. The mystery deepens when we consider the possibility of a spacecraft flyby. Right now, the only mission that could conceivably intercept 3I Atlas is NASA's Juno spacecraft, which is orbiting Jupiter. If engineers execute a daring maneuver in mid-September 2025, Juno could adjust its trajectory to pass within about 25 million kilometers of the comet in March 2026, as it swings by Jupiter. Juno carries instruments that could revolutionize our understanding: a near-infrared spectrometer to analyze surface composition, a magnetometer to detect any magnetic properties, and a microwave radiometer to probe thermal emissions. It would be the first-ever spacecraft encounter with an interstellar object, but the feasibility depends on Juno's dwindling fuel and aging systems. So what would count as a true techno-signature? Nickel without iron and CO2 dominance are not enough on their own. To lean toward technology, scientists would look for patterns that are hard to explain naturally: periodic modulation in emissions, non-gravitational accelerations inconsistent with simple outgassing, unusual reflective geometries, or narrow-band radio signals. So far, none of these have been reported. The consensus today is that 3I Atlas is a natural but chemically exotic comet formed under conditions different from those in the solar system. But the story is still unfolding. In summary, we have hard data showing nickel emission without iron at rates of a few grams per second, and a carbon dioxide-dominated coma with an extreme 8-to-1 ratio compared to water. These findings are scientifically groundbreaking, whether or not they point to extraterrestrial technology. If Juno can be redirected, we may soon obtain the first close-range data on an interstellar object, giving us direct insight into its chemistry and structure. Until then, 3I Atlas remains both a cosmic anomaly and a reminder that the universe is far stranger and more diverse than we imagine. So what do you think? Is 3I Atlas just a bizarre natural relic from another star system, or could it be the first subtle evidence of extraterrestrial technology? Whatever the answer, one thing is clear: we've entered a new era of interstellar exploration.